Today we shall discuss topic geometric progression. This is second topic of third unit. First topic is arithmetic progression. So now we shall discuss geometric progression. What is the meaning of geometric progression? Geometric progression is also known as geometric sequences. So what is the meaning of geometric sequence? A sequence whose consecutive terms have common ratio. For example, we have a sequence whose first term is A1, second term is A2, third term is A3, fourth term is A4 and so on. So a sequence is geometric if ratio of consecutive terms are same, means A2 upon A1 that is equals to A3 upon A2 that is equals to A4 upon A3, that is known as common ratio denoted by R. Now some examples of geometric progressions. Let's start with first example, that is 2, 4, 8, 16 and so on. Here we can see common ratio is 2, means ratio of second term and first term that is 2 and ratio of third term and second term that is also 2. So this sequence is geometric progression. Now second example is in which first term is 12, second term is 36, third term is 108 and so on. This sequence is also a geometrical progression. Now third example in which first term is minus 1 by 3, second term is 1 by 9 and third term is minus 1 by 27. This is not a GP. GP means geometric progressions. Now next example, here first term is 1, second term is 4 and third term is 9. So here we can see common ratio is not same. So this is not a example of GP. Finding another term of geometric progression, geometric sequence, where A is first term and R is common ratio, then another term of geometric progression is A into R raised to the power n minus 1, where R is ratio of consecutive terms, means we can say A2 upon A1. Some other example of GP. So let's start with this example. Write the first five terms of the geometric sequence whose first term is 9 and common ratio is 1 by 3. So this sequence, that is 9. Now AR means first term into common ratio, that is 9 into 1 by 3. So we can find this value and that is 3. Next is 9 into 1 by 3 raised to the power 2 means 9 by 9, so that is equals to 1. So this is required solution of geometric sequence. So now next example in which we have to find the formula of another term, and sequence is 5, 15 and 45 and so on. Their first term is 5 and common ratio is 15 by 5, that is 3. So another term is 5 into 3 raised to the power n minus 1. So now we can find ninth term also. Ninth term is, that is 5 into 3 raised to the power 9 minus 1, means 5 into 3 raised to the power 8, that is equal to 32,805. Now sum of finite geometric series. Series means sum of infinite number of terms of a geometric progression. So if first term is A and common ratio is R, then sum of n terms of GP where R greater than 1, that is equals to A into R raised to the power n minus 1 upon R minus 1. If common ratio less than 1, then formula is A into 1 minus R raised to the power n upon 1 minus R. If common ratio is equal to 1, then sum of finite geometric progression means sum of n terms, that is equals to NA. Now we have to find sum of GP up to infinity where R less than 1. If A is first term and R is common ratio, then sum of infinite number of terms of GP that is equals to A upon 1 minus R, where R must be less than 1. Geometric meaning, one of the most important term of geometric progression. If A, G and B are in GP, then G is geometrical mean of A and B. And if A, G, B are in GP, then we have common ratio that is equals to G upon A equals to B upon G. If these three terms are in GP, so cross multiply G with G, so G square equals to AB and G equals to under root AB. This is geometrical mean of two numbers. Now we have to insert n number of elements between A and B, and a required sequence must be in geometric progression. Let G1, G2, G3, G4, so on G and B the NGMs mean geometrical means between A and B. So G1, A1, G1, G2, G3, G3, G4 dot G and B are in GP. So A R raised to the power n plus 1 equals to B, mean this is n plus 2th term and n plus 2th term is B. So A raised to the power n, n A into R raised to the power n plus 1 equals to B. So here R equals to B upon A raised to the power 1 upon n plus 1. This is the value of R. So Gn equals to A into B upon A raised to the power n by n plus 1. Now we have to find the product of n geometrical means between A and B. Let G1, G2, G3 and Gn be the n geometrical means between A and B. So GA, G1, G2, G3, G4 dash dash G and B are in GP. So product of G1, G2, G3, G4, Gn is that is equals to under root A B raised to the power n. Thank you.